The question says write the equations for the preparation of 1-iodobutane from. These are the three compounds given here, and we have to convert this substance into 1-iodobutane. First one is what? 1 butanol. Okay, let me write 1 butanol. We have 4 carbons, C, C, C and C. 1 butanol means OH group is attached at the end. Okay, satisfy the valency of carbon CH3, CH2, CH2, and this is CH2 is there. Okay, and we have to convert 1 butanol into 1 iodobutane, CH3, CH2, CH2, and it is CH2, and this is iodine is there. Okay, before starting the conversion, always check the number of carbon in the reactant as well as product. So you can see in this case how many carbon are there? 4 carbon. In this case also you can see we got 4 carbon are there. Okay, so number of carbon are same. So we don't need to disturb the carbon chain. We should focus on the group only. Okay, so see how we convert, we carry out this conversion reaction. This is OH is there, we can use a halogenating agent like we have PCl3, PCl5, and then we have SOCl2 is there, and SOCl2 is considered one of the best halogenating agent because in this case we get the byproduct SO2 HCl, automatically they will escape. These are the gases, SO2 sulfur dioxide gas and hydrochloric acid. Okay, in the form of gas they will escape, then we get the main product. So these halogenating agents, what they do exactly, they remove OH and attach Cl. Okay, so we got the substance, we have CH3, it is CH2, and we have CH2, it is CH2, and we got Cl is there. Cl, remove OH and attach Cl. Okay, now in general this is SN2 reaction because we have primary alcohol. Okay, there is no rearrangement. We got 1 chlorobutane, and you can see this is halogen and this is also halogen. Then we can carry out halogen exchange reaction, that is Finkelstein reaction. Okay, you might have learned about Finkelstein reaction. In this case we take sodium iodide reacting in the presence of dry acetone. Dry acetone is acting as a solvent. It helps in intermixing these two substances because this carbon chain is there, no, so this is aprotic solvent. Okay, we have a NAI is there. In this case, in Finkelstein reaction, what is the condition? Halogen attached to the carbon chain should be more electronegative than the halogen present in NAI. Halogen present attached with metal. So this halogen attached to the carbon chain should be more electronegative than this halogen attached to the metal. If I keep the situation, let's say if I keep iodine here and Cl here, then reaction will not take place. This is the condition you need to follow in Finkelstein reaction. Okay, then halogen exchange reaction is taking place. In place of Cl, iodine will come, and in place of iodine, Cl will go. So we get NaCl is separated out from here, NaCl. Okay, and iodine will come, we get this product 1 iodobutane. So 1 chlorobutane is converted into 1 iodobutane via halogen exchange reaction, that is known as Finkelstein reaction. Okay, this reaction takes place in the presence of dry acetone and it is a solvent. Okay, we have the second conversion is there. Second conversion, it says 1 chlorobutane, and you can see this conversion you can find in this conversion itself. This conversion is completing in 2 steps. This is the first step and this is the second step. Okay, if you look at the second step, it says 1 chlorobutane. This is what we have, 1 chlorobutane. 1 chlorobutane is there, 1 chlorobutane, and 1 chlorobutane is to be converted into 1 iodobutane. 1 iodobutane is there, 1 iodobutane. Okay, in single step. So we carry out a halogen exchange reaction. Finkelstein reaction is there. So you can see 1 chlorobutane can be converted into 1 iodobutane via halogen exchange reaction. Okay, so you can see second conversion is also completed because it is given here in the second step. Okay, and anyway the question does not specify whether we have to complete the reaction, conversion reaction, in single step or multiple step. Then there is no problem at all, we can follow this step. Okay, now move on to the third conversion. We have one but1 is there, means double bond, unsaturated hydrocarbon. Third part is but1 in, but we have double bond at the end, 1 in is there. Okay, satisfy the valency of carbon by attaching hydrogen, it is S, and we have H2 is there. It is to be converted into 1-iodobutane, CH3 CH2 CH2, we have CH2, and then we have iodine is there, we have iodine. Okay, here if you think I make this reactant react with HI. Okay, if you think like if HI is reacting, then we can convert this substance into, that is not possible. Why? Because if HI is reacting, if you break it, it is having partial positive charge, it is having partial negative charge, and bond breaking will be taking place this way, because this is what positive inductive effect is there. It will carry partial negative, no positive charge, it will carry partial negative charge. Okay, so I minus will attach to this carbon, and when this I minus is attaching to this carbon, because positive and negative is there, then we get a 2-iodobutane, not 1-ido. We need 1-iodobutane. Okay, understand very carefully. If I make this alkane react with HI, so I will attach to this is your secondary carbon, then we will get 2-iodobutane, not 1-iodobutane. So this reaction is not possible. Okay, so in this case what we do exactly, we have so we do one thing in this case. First of all, we can produce 1-chlorobutane, and 1-chlorobutane can be produced, and once I reach 1-chlorobutane, from here by halogen exchange reaction we can get 1-iodobutane. Pay attention very carefully. In general, to produce primary alkyl halide or primary alcohol, we follow anti-Markovnikov rule. Anti-Markovnikov rule is there. Okay, you might have learned about a reaction. You might have learned about a reaction. Let's say if I make it react with HBr, okay, HBr in the presence of peroxide. So Br will go to the carbon having more number of hydrogen. Br will attach here. So we got 1 bromo. I'm telling the method, number of methods we can follow. You will get 1 bromobutane, like we got 1-chlorobutane. So you will get 1 bromobutane, because if I make it react with HBr in the presence of peroxide, 1 bromobutane, and then you can carry out halogen exchange reaction, then you will get 1-iodobutane. So this reaction is possible. But apart from this, if I make it react with HBO, okay, let's say if I use the reagent hydroboration reaction, boration reaction is there in HBO, we say HBO. So in this case, what is the reagent we use? This is what B2S6 is there, and this is OH minus ion, and this is what we have H2O2 is there. H2O2. H2O2 peroxide effect is there, means this is a kind of indirect hydration reaction, addition of water molecule according to anti-Markovnikov rule. OH minus ion will go to the carbon having more number of hydrogen. So OH will go here, OH minus ion will go here, then H will come here, because in this double bonded system this carbon has more hydrogen, this carbon has less hydrogen. So anti-Markovnikov rule, OH minus ion will attach to the carbon having more number of hydrogen. So what is the substance we got? CH3, it is CH2, then we are getting CH2, and this is what? CH2, and this is OH is there. We got 1 butanol is there, and we know how to convert 1 butanol into iodobutane. Okay, first I will convert this 1 butanol into 1 chlorobutane. Okay, 1 chlorobutane, and then 1 chlorobutane by halogen exchange reaction we can convert into 1 iodobutane. Okay, so we make it react with halogenating agents PCl3, PCl5, yeah, SOCl2 is there. Then we get CH3, CH2, CH2, and this is CH2, and it is Cl. And then we can carry out halogen exchange reaction. Dry acetone is there. Dry acetone is there. So like this we can do the conversion. Keep in mind you should not take HI here, otherwise you will get 2-iodobutane. Whether you carry out this conversion or you can make it react with HBr in the presence of peroxide, you will get 1 bromobutane, and again you can carry out the halogen exchange reaction, you will get 1 iodobutane. If you like this video, please share and subscribe to the channel.